Hey guys, what's up? It's Charleston. Today we're gonna be doing problem 1.8 in the textbook. If anyone knows how to do problem 1.7, that would be nice. And I left off 1.6b through d because they're just extensions of 1.6a. So you guys can dig into that one more yourself. I just didn't feel like computing all the autocorrelation or writing it all out and computing it, but I did the first one, so the process is there, and so you just follow that same process. But anyway, we're going to get into doing 1.8. We're going to do 1.9 this next upcoming week. Try to do 1.10 and 11. I get through more of these chapter questions, and then we're going to get into chapter 2, which is a lot more fun. So, cool. Alrighty. So we're doing problem 1.8 today. Problem 1.8 says, find the autocorrelation function of x of t of a cosine t f naught of t plus phi in terms of its period. T naught is equal to 1 over f naught. Find the average normalized power of x of t using the fact that autocorrelation at tau equals 0 is equal to the average normalized power. So first what it gave us, it said is that x of t, I use red today. Okay, interesting. I'll use red here to write these notes. So this is the known. So this is the known r slash given. So what's known is we have a cosine 2 pi f naught of t plus this guy, and then we know px is equal to rx of 0, and t naught is equal to 1 over f naught. And they want us to find. So they want us to find px. So find px, and they also want us to find rx of tau. So what do we know? Well, what we know is we know that the autocorrelation definition of a function tau is given by the integral from minus infinity to infinity of x of t plus x of t plus tau dt. Right? And here we know that since this signal is periodic, we obviously can't use minus infinity to infinity, because when you plug infinity in here for t, it'll go to cosine will shoot off to infinity, so it'll be undefined. So what we'll have to do is expand the definition to a periodic signal. So it'll be rx of tau is equal to, that should be 1 over t from minus t over 2 to t over 2. X of t times x of t plus tau dt. If I believe correctly, let me just check real quick with my notes. That would be the right answer. Exactly, yeah, so that's exactly what we'll do here. So now we need to just compute the autocorrelation here, this cosine function with a shifted version of itself. So now we're going to get into the computation section. I'll try to organize the board a little better now. My future videos kind of like this, so it makes it a little more clear. Computation is going to be a rx of tau is equal to 1 over t integral from minus t over 2 positive t over 2 times a cosine 2 pi ft plus phi times, so over here what we're going to end up with, we're actually going to end up with times a cosine 2 pi f times t plus tau in parentheses, because we're doing shifting t, but t is multiplied, so I'm going to put it inside parentheses itself, plus phi, all of that dt. Alright, so to solve this, first we want to factor out these a's, right? These a's are not dependent on this d of t. Factor out the a's, we're going to end up with a squared over t times the integral from minus t over 2 to positive t over 2 of a cosine of 2 pi ft plus phi times cosine of 2 pi ft plus 2 pi f tau plus phi dt. I'm gonna stop writing the dt, guys, because I get lazy, but you know it's there. So now it turns into a squared t minus t over 2. Okay, so what I'm going to do is I'm going to use this principle of a cosine. So I'm going to use a principle here. I'm going to just draw a little box here. So this is our workspace. I'm going to use this principle here. So principle. So the principle is cosine x times cosine y will equal cosine x minus y plus cosine x plus y divided by 2. Alright, so what we do is take this inside part, subtract it from this part. So this f of t will cancel. And then over here we're going to have phi minus phi, so that'll cancel. And then we're just left with minus t pi, 2 pi f tau. This is cosine 2 pi f tau. For this x minus, this is x minus y. And then we're going to add these two together, so then we end up with plus cosine of 4. So 2 pi plus 2 pi is 4 pi ft. And then we have plus 2 phi, and then plus 2 pi f naught tau dt. All of this obviously divided by a half. We're going to take this half back outside again. This is going to end up being a squared divide a squared 2t. And then we're going to take the antiderivative of this. So this is, the antiderivative of this is going to be, this is just a constant because it's based on tau, not t. So this is a constant. So this is just going to be cosine 2 pi f tau t. And this is plus, this is going to be sine here. So because this inside part is dependent on t here. And we're differentiating with respect to t, so it's going to be sine of 4 pi ft plus 2 phi plus 2 pi f tau divided by 4 pi f from minus t over 2 to positive t over 2. Okay, now we're going to evaluate this. So this one we're going to get a t over 2, this one we're going to get a minus t over 2. And the thing about this is, hallelujah. Let's see here, hold on. So we're going to get this t over 2 minus t over 2, that's going to add up to be cosine. So it's going to be 2 so it's going to be 2t. When we add these two from t over 2 to minus t over 2, right, we're going to get cosine 2 pi f naught tau, and then we're going to get t over 2 minus t over 2, that's positive 2, so that's going to be t minus negative t over 2, so that's 2t over 2, so it's going to be 2t here. And then over here we're going to get a sine of 4 pi f naught of t. So we get a sine 4 pi f naught of 2t. And then we have a sine minus a sine 4 pi minus 4 pi to a t. So these are opposite to one another. So we're going to use another principle here that sine of x is equal to minus sine of minus x. And so yeah, guys, I'm sorry. I blame the American education system, of course, for all my faults. But no, really, here I meant to say sine minus sine of x is equal to sine of minus x. And so I'll show it just a quick little, I'll flash up some images right here, but you'll see, for example, a minus sine of 90 is equal to sine of minus 90. They're both equal to negative 1, that is, for minus sine of 90. And for sine of negative 90 as well. And so you'll see here. Anyway, just want to make a quick point before we moved on in the video. The fact that these are equal when we add this together, when we add these two together here, it should cancel one another out here. So we have a sign, we have a minus, a negative. Oh, so this is this is going to be negative 2t, and this is minus that, and then we're adding them together. They should cancel one another out. These are equal. We're gonna add. We add them together. We should cancel one another out. Yeah. Okay. So then all we're left with is a squared 2t times cosine 2 pi f tau of 2t divided by 2. So these 2's are going to cancel and these t's are going to cancel. In the end, we end up with a squared cosine of 2 pi f tau divided by 2. So that's going to be our rx of tau function. So let's erase this. Let's erase all of this. And just erase this at the bottom here. We only need this space right here. Okay, so what did we find? We found Rx of tau is equal to a squared over 2 times cosine 2 pi f naught of tau. And now we need to find Px. Well, Px is equal to Rx of 0. So we plug in 0 here for tau. And this becomes cosine of 0. Because anytime you multiply something by 0, it's 0. So it's going to be a squared over, I don't know, cosine. Cosine of 0 is 1. Is equal to 1 here. So it's going to be 1 times a squared over 2. So it just ends up being a squared over 2. And this is our final answer right here. So that's that problem. Not too difficult. Pretty simple. And that's how you do it.